Hello, good morning, everyone. Please hold on. We are expecting more participants. Please hold on for another couple of minutes and we'll start the session soon. Good morning, everyone. I think more of your friends would be joining in, but let's start anyway. Let's not delay anymore. Welcome to the workshop on exploring data analytics and data science. This will be the first of the 6 workshop series SkillLink is organizing as part of the College Connect program of IIT Bombay's Mood Indigo. Before starting the session, I'd request all of you to please stay on mute during the session, and we welcome you to post your questions on the chat box. We will handle these questions during the Q&A session. As you might know, we'll be providing co-branded certificates for all the attendees, and we will be floating a Google form at the end of the session. Make sure to fill it up. It will be used as your attendance and certificates will be delivered. Okay, I'd like to welcome our instructor, Ms. Divya Shravanti today. Ms. Divya has 8+ years of experience in management consulting space across 3 multinational companies. She's a strong business development professional and an experienced analyst, skilled in data science, W, ClickSense, and many more. Currently, she is working as a data analyst with Informatica. Without further ado, I'd like to hand over the session to Ms. Divya. Good morning, ma'am. You can take it forward.
Thank you. Thank you for the introduction. Hello, everyone. Good morning. I hope everyone is doing good. So as the SkillLink already mentioned about me, I'm Divya Shravanti, and I have like 8 years of experience in this field, and I'm currently working with Informatica. So welcome to our webinar, Exploring Data Science and Data Analytics. This will be going to get the knowledge about all the fields related in data science and what are the tools used in data science and data analytics. We will get into the deeper depth of what the content we have, what is the process we follow in this field. So for today's agenda, we're going to look at, we will look at what is data science. First, the basic concept of what is data science, and the life cycle of data science, what we will do inside and what processes we will follow inside the data science life cycle. Data analytics and the BI tools. As data science also includes data analytics, we will also look at the life cycle of data analytics, and we will see what are the BI tools we will use in this process. And we will discuss about how this BI analytics is playing an important role in data science. We will look at all the prerequisites a student must have to explore this domain. And we will discuss about what are the industry trends and how data is actually ruling all the domains now. At the end of the webinar, we will be discussing about what is the career path and what are the opportunities you have in this data science field. Let's jump onto our data science, what the basic definition of data science. So before moving into the actual concept, let's talk a bit about all the concepts which are related to this field interconnectively to some concepts. So we are hearing a lot of buzzing words nowadays in the data field, like artificial intelligence, AI, machine learning, ML, deep learning, etc. so on. So where exactly data science fall under this hierarchy? It is equally important to know about all the other terms in this field as well. So I will just explain a simple breakdown. The first one is artificial intelligence. So AI means teaching a computer to mimic the human behavior in some sort of way. In the subset of AI, data science will come. So data science refers more to the overlapping areas of statistics, scientific methods, and data analysis. These methods are used to extract meaning and insights out of the data. So data science will fall under the AI, artificial intelligence. So next subset of AI is machine learning. It consists of the techniques that enables computers to figure out things from the data and deliver AI applications. So we have two subsets under artificial intelligence. One is data science and one is machine learning. Under machine learning, we have deep learning. This is a subset of machine learning that enables computers to solve more complex problems. So data analytics will fall under data science. So the flow chart looks like this: artificial intelligence, They have two subsets. Artificial intelligence have two subsets: data science, machine learning, and data science has data analytics. Machine learning has deep learning. This is a simple breakdown of all this buzzing words we are hearing right now. And going to what is data science actually. So data science 25 years ago is referred to gathering and cleaning data sets and applying statistical methods to that data. In 2018, data science has grown to a field that encompasses data analytics, predictive analytics, data mining, business intelligence, machine learning, and much more. So data science is one of the most exciting fields out there today. This field is growing so rapidly and revolutionizing so many industries. So we call it the data science as collective processes, theories, concepts, tools, and technologies that allow the review, analysis, and extraction of useful knowledge and information from the raw data. So this one is a basic outline of the data science. So collective processes, theories, concepts, tools, and technologies, which will allow us to do an analysis and do an extraction of useful knowledge, right? With all information from the raw data. So there are like so many definitions out there for the word data science. This is trending a lot. So there are so many definitions coming out. And why? Because it is not a tool or a software. Data science is actually a process. It combines multiple fields like statistics, scientific methods, AI, data analysis. We will do all these things to extract the value from data. So data science is to uncover patterns inside the data. Use data to make an inference to predict an outcome. So we will use this data to predict all the outcomes from the data, which will give us a meaningful insight. So data science is responsible for bringing us new products, delivering breakthrough insights, and making our lives more convenient. So a groundbreaking study in 2013 reported that 90% of entirety of the world's data has been created within the previous 2 years. So 90% is only created from 2 years. It is projected that we have already created 2.7 zettabytes of data, and by 2020, that number increased to an outstanding number of 44 zettabytes. So this information, wherever we are gathering it from, wherever it is created from, this will help us to make better decisions. Now we got to know what is the basic meaning of data science. So how does this data science work? Data scientists must be skilled in everything from data engineering, maths, statistics, advanced computing, and visualizations. They will be able to effectively process this masses of information and communicate only the vital bits that will help drive innovation and efficiency. They also heavily rely on this artificial intelligence, especially in the subfields of machine learning and deep learning, to create models and make predictions using algorithms and other techniques. So if you see here, this is the actual data science life cycle. This has generally 5 steps of life cycle inside the data science. The first one is capture. Next one is prepare and maintain. The third one is pre-process. The fourth one is communicate. Sorry, the fourth one is analyze. And the fifth one, the final step, is communicate. All these 5 different stages required different techniques and different tools. So we will understand what are these stages first. What is the work which is done inside? Then only we will understand what is a tool we might need to use for that process, exact process. So what is capture? So data is actually the foundation of all these processes, all the data science, machine, whatever it be. Data is the starting cell of everything. Your route to work, like your most recent Google search from the nearest coffee shop, or your most recent Instagram post about what you ate, and even the health data from your fitness tracker, that all the data from two different, they are important to all the data scientists in different ways. So this is the gathering, the capture process is the first step of the life cycle of data science. And this is a gathering of raw structured and unstructured data from all the relevant sources. Like they can use any method to actually gather this data from all the relevant sources, from manual entry and web scraping to capturing data from systems and devices in the real time. These are some of the data sources. They can be capturing the data from like e-commerce websites, social media posts, images. They can scrap directly the data from the web, and they can use the web API too. So we have different stages in data capturing as well. So we have like four different types of data capturing, 4 different stages of data capturing, which we use inside the capture process. So the first one in the data capturing is data acquisition. Data acquisition, which is also known as data collection, is the very first step in any data science project. The complete set of required data is never found in one place. It is actually distributed along all the business applications and systems. So data collection is a very important step in the capture process. The next one, data entry. Data can be created with new data values for the enterprise by human operators or devices. Like it is a total time-consuming process, but it is actually needed in certain cases. The data entry will create new data values in your already existing data. The third one is signal reception. Another source to capture data is through data devices, typically important in control systems, but now more important for information systems with the invention of this Internet of Things. The last one in the capture process can be data extraction. Data extraction is a process that involves the retrieval of data from various sources. They could be like web servers, database, logs, and online repositories, etc. You're actually under constant surveillance, if I say. Whatever you use, whatever technology you use, your data will be captured everywhere. So almost every interaction with technology includes data. Your Amazon purchases, Facebook feed, Netflix recommendations, and even the facial recognition required to sign in into your phone, everything is data to someone. So your email account, YouTube, whatever applications, mobile applications, if you like install one kind of app into your phone, it will ask to access to all the other apps, right? You have to give the control or deny the control to access all the other apps. Like Facebook, it gets the data from your Instagram, your WhatsApp. It will see all your discussed chats, even if it is encrypted. It will actually have the data then, and it will throw ads based upon your whatever chat you're going on. You might be surprised that you can be talking about something at your post day, pre-day, and you might be getting the same ad the next day, right? So we might have seen these cases so many times where we are seeing some ads which we spoke inside a chat or somewhere. This one is all the data digging part. They will capture the data, they will throw you ads according to your interest. So digging out required and meaning knowledge from the data is actually done here. So the next process in the life cycle of data science, the second one is preparation and maintain. So what happens to all this captured data? We have to do some process, right? It can be unstructured, right? Raw data. It can be in different formats, and you can get the data in different ways, and you have to do some structuring of the data. So in this maintain and prepare process, we will go through some steps where we will go with data warehousing. Data warehousing emphasizes the capture and storing of the data from the different sources for access and analysis. This is kind of a repository for all the data collected by an organization. So most of the organizations, most of the companies or business will have this data warehousing concept to store all this data so that they can access this data later on, because they are also storing the historical content as well. They can do some analysis. Okay, how am I doing this year when compared to the previous years, like that? So they do collect every data in the data warehousing. So the data cleansing part or data cleaning is a process of identifying and removing or correcting the inaccurate records from a data set. It can be table or database, and it can refers to an unrecognized or unfinished, unreliable, like you can say inaccurate, missing values, duplicate values, everything which are non-relevant of the data. And they will do all the restoring part, they will do remodeling, or they will remove the dirty or raw data. This is the cleansing part. Whatever you get the capturing part, you already will get the data from different sources, and you do this cleansing for the data to be clean to the other users to do their analysis. We have a stage called data staging. This is an intermediate storage area, and this is used for data processing during the extract, transform, and load process, which is also known as ETL process. The data staging area sits between the data sources and the data target. Data target can be a repository of the data, which are often like data warehouses, data marts, or data repositories. This is where you actually store the data. So this data staging process is in between the whatever data source you collect and wherever the target is, like wherever you're going to store your data. We have one more step called data processing. So during this stage, these are all the stages when we go with the prepare and maintain part. So data will be going through all these stages to appear to the final stage. So in the data processing stage, the data is processed for interpretation. So processing is done using this machine learning algorithms. Through the process itself may vary slightly depending upon the source of data being processed, which can be data lakes, social networks, connected devices, etc. And its intended use. Like, what are we going to do with this data? Are we examining advertising patterns? Or are we examining medical diagnostics from connected devices? Or are we like determining some customer needs? So whatever your ultimate goal is, the data processing will keep this in mind and do the data processing. For the interpretation, interpretation means the ultimate target of what are you looking for. And the next one is data architecture. So data architecture is a framework. It is built to transfer data from one location to another location efficiently. So all the data architects, what they will do is they will build these models and rules that govern that data is to be, how the data is to be collected. It also controls how the data collected should be stored, arranged, and integrated, and put this data into a good use for the data systems and also for the organizations. So in short, what is data architecture is about? It will set some standards for all the data systems as a vision or a model of the functioning for the data system interactions. That means all this data structure will follow a model to finally go into our data warehousing, and where all our data goes through some structured model. Okay, you have to be like this, you have to be like this. And they will create a model to enter that data into the data warehouse. So that one is called data architecture. So if you see here, with all this processes coming up in this prepare and maintain, these are the main steps when you do this prepare and maintain the data for. So maintain is like maintaining the structured data in your data warehousing. And we have data standardization in between. So we have data cleansing, where we will go with all the anomalies, and we will cleanse the data for if you have to go through splitting of the data or merging of the data and remove unwanted data, etc. You will have to go through all these processes to finally push the data into the data warehousing. So the third process in the data lifecycle would be pre-process. So what do you do with all this cleaned data? You have all this structured in place, and you have the data in the warehouse, and the data is readily available, which is structured, right? So what do you do with all this, which is the cleaned one, structured one? So now that the data is collected and stored, we can move on to the next step. This is called pre-processing. In pre-processing, we will go through some steps. Data mining. Data mining will fall under pre-processes, and it is about finding the trends in that particular data set. These trends are used to identify the future patterns. It often includes analyzing the vast amount of historical data which was previously disregarded. This one will give you identifying the patterns inside the data. And we have clustering and classification. You already identified the pattern and you need to do clustering and classification. So clustering is actually the task of dividing or classifying the population. Let's say you have some population or you have some data point. That clustering process will divide it into a number of groups such that the data points in the same groups are more similar to other data points in the same group than those to the other groups. Like the clustering, just you can imagine it with a group of people which has the similar features, like similar mentality kind of. So in simple words, the aim is to segregate groups with similar traits, and we will assign clusters to them. So all the similar content will fall into one similar cluster. And data modeling is a process of producing a descriptive diagram of relationships between the various type of information that are to be stored in a database. So whenever you store data, so this will be coming up with different tables, and you have to provide a process, a descriptive diagram of relationships between these tables. So whatever data you have processed or cleaned and went to the data architecture and finally went to the data warehousing has to have some data model. That means the structure of the data. If you just can compare it with an Excel sheet, how are my columns looking like? How are my rows looking like? What is the structure of the data? This is very important to provide the relationship for this data to other tables. The final step in the pre-process is data summarization. Summarization is like key data mining concept, and this involves techniques for finding a compact description of the complete data set. So you need to give some description about the data set, right? So what does the data contain? What it is all about? This one is called data summarization. You will describe what is the data inside the data set. This is a very really simple term or a short conclusion after the analysis of a big data set. So this data summarization will be a great importance for data mining. So whenever you are accessing one kind of set of data, if you look at the data summarization, and you will be understanding all the data content inside. What is it about? What are the trends? What are the clusters they have? This is all called data summarization. So by this end of the data summarization, we will be coming to an end of the cycle of pre-process. And we went through all this technical part, and we are going to analyze the data. We collected the data, we structured the data, and we kind of mined and summarized and all the data. We gave everything which is coming onto all the processing part. And the exciting part starts from here. We will be going to analyze the data. So now that you have all the classified data and you have modeled it, it is actually the time to analyze your data. So how are you going to analyze your data? And we have some processes in this as well. We have like some steps to follow. So in the analyze, we have exploratory and confirmatory process. So in this process, you will be going to examine the data, and this then will fall under two phases. It can be exploratory or it can be confirmatory analysis. The two operate most effectively side by side. So exploratory data analysis is sometimes compared to the detective work. So you're going to explore your data. You're going to be a detective to find out some whatever insights you can be getting from that data. So this is like a process of gathering evidence. So what is the data like? What it has inside? This is all exploratory from the word itself. You can see how it is like exploratory. And the confirmatory data analysis is comparable like to a court trial. You're providing all your evidence to a court and you're confirming it. That is called a confirmatory data analysis. And we have predictive analysis. Predictive analytics is the process of using data analytics to make predictions based upon the data. So this process uses data along with analysis, statistics, machine learning techniques sometimes to create a predictive model for forecasting the future events. Like you already have the data, you analyzed it with exploratory and confirming, okay, my data contains this, and then I'm damn sure that it is the data will be confirming these trends. And predictive analysis will give you some predictive things you can do in the future events. So this analysis is used to determine like customer responses or purchases, as well as like to promote the cross-sell opportunities to someone. So these predictive models help businesses attract, retain, and grow their most profitable customers. Let's say this is an example. They are going to predict what they're going to sell and what they're going to sell in different regions. This is the predictions they're going to be, and they will be manufacturing according to that. They are like attracting their customers. So many companies use this predictive analysis to forecast inventory and manage resources, whatever the companies is going under. Like if they have to make some development in the products, they have to go through some predictive analysis, right? They have to, okay, predict that, okay, I'm going to sell 10 products in this month. So I will be requiring, if I just gain more attraction from the customers, I will be requiring to produce like 20 products next month. So that can be the predictive analysis. We have regression analysis. So regression analysis is a form of predictive modeling technique. This will investigate the relationship between the target and the predictor. So the target is called dependent variable and the predictor is called independent variable. And this regression analysis is used for forecasting time series modeling and finding causal effect relationship between the variables. Like if you variables are, let's say variables are like whatever content you have it inside. Like let's take the example of a column. You have a variable of one particular data set and one particular name. So what is the relationship between all these variables? And if you're going to use this regression analysis, you will be investigating the relationship between the dependent and independent variables. And these techniques will be so much useful when you're forecasting the data according to the time series. So the next one would be text mining. So in the analyzation part, we will do text mining. So this refers to using data mining techniques for discovering useful patterns from the texts. The text mining, the data is like so unstructured. Information and relationships are hidden into the language structure and it will not exploit as in the data mining. So you can actually think it like, okay, you went to a movie and you just gave a review and you want to find out how the movie is, how actually people discussed about it. Is it good or is it bad or is it neutral? How are you going to do that? Based upon the words you used in your review. So text mining will mine all this data and it will throw an insight of whatever you used, the words you used in that particular text mining, and each word will be related to one particular expression. Let's say sentiment analysis. You are writing something and it is related to one particular sentiment. This is called like a text mining. We also have qualitative analysis, like when the data is not in the form of numbers, it is like even tougher to understand. Numbers will be actually easy for the data to analyze, but if it is like qualitative, the data is defined as a data that approximates and characterizes. So this data, they can be observed and recorded, but this data type is like non-numerical in nature. This type of data is collected through methods of observations like one-to-one interviews, conducting focus groups, and similar methods. This is called qualitative analysis, where the data is not related to numbers. You will be going to only have the qualitative data. So the qualitative data analysis is like simply the process of examining the qualitative data to derive an explanation for a specific phenomenon. This analysis will give you an understanding of your research objective by just revealing the patterns and themes in your data. So what data scientists do is, and they will build models to get the benefit from this qualitative methods. So in this analyzing part, we went through some steps where we'll do different kind of analysis to actually what kind of analysis will fit the data. I mean, we have to go through all this analysis and we have to select one kind of analysis based upon the data. So this is like choosing the best fit model. So whatever I had told, the analysis, whatever we spoke through till now, it's like choosing this particular model according to the data. So we are training the data, we are testing the data, and we are going to extract insights from the data. The final step, the visualization of the results. We have been very hard with going with all this data, and we just bought all the insights, we did everything, and finally we had to present it to someone. And when we are presenting, you don't want to show all the things you have done, right? You want to make it very simple, and you want to present the data so that the final user will understand it really simple. And for that, you need the visualization part. So how are you going to display your results? In this visualization part, we have data reporting. So this reports communicate information which has been compiled as a result of all the research and analysis we have done with the data. And it will also report the issues. So these reports can cover a wide range of topics that usually focus on transmitting information with a clear purpose to a specific audience. So good reports are like documents that are accurate, objective, and complete. This is called data reporting. You are finally giving the data to the final end user with all the analysis you have done inside your data set. Data visualization, this is a graphical representation of information and data of whatever data you have. By using these visual elements like charts, graphs, and maps, this data visualization tools provide an accessible way to see and understand the trends, outliers, and patterns in the data. Because everyone, if you're just presenting out to the content, all this content to the final user, everyone might not understand the technicality inside the data, whatever you have done. So you have to find an easy process to finally present it to someone, right? So that's where we will do data visualization to make some insights and tell everything to our final users. So business intelligence is the integral part of the data science. To do a predictive analysis, first we have to know what went wrong, right? So hence, this business intelligence is a simpler version of the data science. So whatever you do, whatever you have done with all the data science life cycle, business intelligence will make them to understand whatever happened, what are the insights, and what you must do to recover from that whatever insight you're given. So decision making is a final step you're going to take from all these processes, all the life cycle of the data science. So the importance of a data in decisions lies in consistency and continual growth. It enables companies to create new business opportunities, generate more revenue, predict the future trends, optimize their operational effect, and just produce actionable insights. Whatever decisions they will be taking is all related to these parts. So they might have to provide revenue and generate revenue in some parts, or they have to predict some trends. Whatever they are looking at, the final decision making comes out of your visualization or whatever the data you're going to present. This is the last step of the 5 stages, and all these 5 stages requires different techniques, programs. In some cases, you might have to have a different skill set as well. So this is like one half of the data science. So we already know that analyze and visualize comes under data science, and data analytics will fall under data science. This is like a part of the cycle, the last 2 steps of the cycle. This data and analytics and all this BI tools comes in the last 2 steps of whatever you're using, right? So in this slide, we're going to look at the process of the last 2 steps only. Okay, how are BI tools going to get this data, and how is the flow of this data analytics? So if you look at the data analytics and the BI tools, whatever we have discussed right now, the data collection part and all these organizations and all this organizing of data and clearing the data, cleansing the data, etc., will come into your first step. If you see here, there is a database symbol, and it is going to in some particular folders, right? So you're just dividing the unstructured data to a structured data. So this is like a very first step of everything. So, and as businesses are continuing to grow, they're generating more and more data. And this is the reason why they are actually investing huge sum of money in this data maintenance and analysis. So data maintenance and analysis is one kind of step, and you have to perform the analytics part right after the data. So after the data collection and everything organizing, you have to do your analytics, get the answers for your business. You have to provide insights, and you have to make a meaningful data interpretation out of your unstructured data, which went through all these processes. So analytics is like the output part of this all entire life cycle. And you have to do this analytics and present it in a very descriptive manner to the final advisor, like final user. That's where we use BI tools. BI is business intelligence. These tools are actually used to perform the data analysis to derive that answers from the business questions. If a business comes for you and asks you something, okay, why am I not selling any products in some area? What can be the root cause of it? So analytics is like analyzing the data and presenting it to the final user is coming under BI. So there are like so many tools available for this BI space, and one particular, I mean, some examples for this BI tools are like we have Looker, ThoughtSpot, ClickSense, Power BI, Tableau, and so on. Every tool has its own importance, and we cannot compare with one tool with the other tool. So we are just quoting a famous quote, like, it is important to understand what you can do before you learn to measure how well you seem to have done it. So you might be doing all the process, and if you don't have a final goal of what you can do with the data, so whatever process you are doing with all this difficulty and following all this process might go vain, right? So you have to understand your final goal of what you can do with this data. That's what John Turkey, who is a developer of exploratory data analysis, is saying, telling us to follow. This is just like a code of like what you might have to do whenever you have the data. So where does this BI analysis stands in all this process? So data analysis is like an iterative process that helps you get closer to the solution. And every iteration has a cost associated with it. So a simple bar chart will help us understand, okay, who, which, whatever questions we have from the data. And this data analytics is a process that creates clarity out of chaos. And this allows us to make sense of what we see in the real world by using data and advanced methods to create insights that we can use we can solve real-time problems what we're having outside. Not only the business operations, we can even solve an operation which is inside the government, or just provide a solution from their problem. So this data analytics helps us understanding what's happening, what's likely to happen next, and what we should do about it. So if your business, you can in your business, you can use this data analytics to grow, become more profitable, and create maximum value in the market for your shareholders. So in this data analysis, we already discussed about the analysis we have in data analysis. We have 4 different types of data analysis that are widely used, and they are descriptive analysis, diagnostic analysis, predictive analysis, and prescriptive analysis. We already discussed some kind of analysis in the previous step, in the analyze step, right? So this data analysis mostly will follow these 4 analysis: descriptive, diagnostic, predictive, and prescriptive. And what is descriptive analysis? So descriptive analysis is like first type of data analysis, and it is like foundation for all your insight. And you can consider this data type to be the simplest and most commonly used in all the today's business. So descriptive analysis answers the question, what happened? This actually, whatever you're doing with the descriptive analysis answers this question, what happened, by summarizing all the past data. So it usually does it with the form of the dashboards. So descriptive analysis comes with different uses, but the biggest one is being used in business to track the KPIs. These are key performance indicators. The key performance indicators describe the performance of the business based upon some benchmarks. Each company will have their benchmarks, and they will go through this descriptive analysis to actually show how this KPI is performing in your business. A small about diagnostic analysis is like what now we already went through of descriptive analysis, like what happened. So next step you have to follow is and to be implemented, and you have to dive deeper into your data and ask why it happened, right? So this is a part where a part where the diagnostic analysis comes into action. So the diagnostic analysis take all the insights you found from the descriptive analysis, and it drills down into the data, and it will actually find the causes of these outcomes. The organizations seem to use this type of analytics often as like it will help you to create more connections between the data and lets you identify the patterns of a particular behavior. Predictive analysis is like you're going to answer the question, what is likely to happen? So in predictive analysis, the business uses previous data to make predictions for the future outcomes. We already discussed about the predictive analysis, and this one will make the connection from the past historic data to the future data. Predictive itself, the word itself is like predicting something out of the past historic data. So this step of data analysis is like one step higher than the descriptive and the diagnostic. Predictive analysis uses the data which we summarize, and like it can make logical predictions from the data what we have. So this is completely rely on this entire part is relied on statistical modeling, and this might need some technology and manpower to actually do the forecasting. Prescriptive analysis is the final step of your data analysis, and the prescriptive analysis is considered to be the most sought after all, and few organizations know and are truly equipped to perform it. This is like a frontier of data analysis that combines the insights from all your previous analysis and determines the right course of action to take and solve the current problem or even make a decision. So it utilizes all this data for technology, and it has to have some huge organizational commitment whenever you're doing with some organizations. So that is why these companies have to be sure that they are not only ready, but also willing to put forward the effort and resources. Like it will show you everything and what you got from the insights, but what you're going to do. And this one is a final step of your data analysis. And if you're looking at the business intelligence before data science jumps into predictive analysis, it must look at the patterns of the behavior and past provides. And you have to analyze them, draw insight from them, and inform the path for the forecasting. So this one, business intelligence, will focus on these questions like how many units were sold in that particular region, which types of goods were sold where, how did the email marketing perform last quarter, etc. What everything is like business intelligence. The name itself, you're giving some intelligence for your business. So what does this business intelligence will do? Business intelligence analysts, what they will do is they will apply all these measures in the data science for the business performance. But in order for the business intelligence analyst to achieve all this, they might have to employ some data handling techniques. So the starting point for all this data science is data. We already know data is the first cell for everything. So once the relevance data is in hands of the BI analyst, they will go through all this things like KPIs, monthly revenue, customer sales, etc. And they must quantify the observations they have made and derive some insights out of the data. So this is all about business intelligence in this entire data science concept. So where this business intelligence is standing in this data science. So when you're talking about data science is all about like you're telling a story out of your data. So apart from handling all this numerical information and everything, data science is particularly about business intelligence, and it is about visualizing the findings, creating easily digestible images like bars or graphs or charts, anything that from the data. And the images will be supporting all your numbers. So after all these levels of management should be able to understand the insights from the data and inform their decision making, right? So business intelligence analysts, what they will do is they will create these dashboards and reports accompanied by all these graphs, diagrams, maps, and other comparable visualizations to present their whatever relevant findings they have got from the data to present to the final business advisor. So this one is falling under this entire BI suite. This BI actually relates to databases, ETL, and visualization. Databases for data, ETL is extract, transform, load, all the data handling part in between, and finally visualization. BI falls under this all the parts, and everything will be done for the business intelligence. So we went through all the technical part, we went through all the processes, what is the life cycle for data science, where is business intelligence standing, and what is the importance of data analytics in business intelligence. What are the steps we will do in business intelligence which are related to the data analytics? And we went through all the technical part, right? So this is the actual theoretical technical part of whatever you do in the data science. So the tools you're going to use in this each and every step, or what are you seeing right now. So the languages of data science are for anyone who are just getting started with the data science journey. The range of technical options can be like overwhelming. So there is like so much of amount of choice when it comes to the programming languages. So each has its own strengths and weaknesses, and there is no right answer to the question of which one you should learn first. The answer to that question depends largely on your needs, on your data requirement, the problems you are going to solve, and who are you going to solve them for. Python or SQL are the languages that we are recommending you to consider first and foremost. The languages you choose to learn will depend on the things you need to accomplish and the problems you need to solve. So these languages will be completely based upon your requirement and your data, how the data is looking, right? So it will also depend upon what your company you work for, what role you are doing, and the age of your existing application, because it has to connect with some other tools to do all this data cleansing or data manipulation part. So the R is actually an open source programming language. It is completely free, you can download. And this is an environment for developing the statistical computing, graphics, and everything. So R is like a most popular programming language among the data scientists. And it contains a broad variety of libraries and tools for cleansing and prepping data. You can even create visualizations, and you can do the training part of evaluating machine learning and deep learning algorithms. So this is the vastly used language in the data science scholars and researchers. So next is the Python. This is for general purpose. Python is actually trending right now in the data science field, but it is equally important as R. So this one is general purpose, object oriented, and it is high level programming language. So this one emphasizes code readability through its distinctive general use of the white space. Even in Python, you will have different libraries for the data science, which will support the data science tasks. You have NumPy, and you have Matplotlib for the visualizations, Pandas for the data manipulation and analysis, etc. You have different libraries in Python as well. The SQL is a bit different from the languages we have covered so far. So first of all, the SQL is actually SQL. We might pronounce it as SQL, and we kind of used with the abbreviations, and we pronounce it as SQL, but the acronym is actually Structured Query Language. And most people do not consider SQL to be like other software development languages, because this is like a non-procedural language, and its scope is like limited to querying and managing data. So while it is not a data science language, but data scientists will use this SQL language regularly because it is simple and powerful. Like data architects will use SQL most used language in the data architects. So The couple of facts about SQL is it have first appeared in 1974, and we have much more. It's much more older than Python and R, and it is too old than the coming languages, but it is a really powerful language out there. And knowing SQL will help you many different jobs in data sciences, like you can be in data analyst part or you can be in data engineering part. So while performing these operations with SQL, you get the access to the data directly, and there is no need to copy the data beforehand. This one follows this American National Standard Institute, which in the short form we'll call ANSI standard. That means if you learn SQL and use it with one database, you will be able to easily apply the SQL knowledge to other databases as well. Because like there are so many different SQL databases available. If you learn the SQL, you might be able to directly associate with any other databases like MySQL, PostgreSQL, or Apache, etc. The syntax of the SQL you write might change a little bit based upon the relational database management, but it is like really easy. If you know SQL, it is really easy to access other databases. So these three comes under the language section. So these are the languages we use in the data science. We have an open source tool called d3.js. D3.js uses the JavaScript library, and it is actually used to create interactive visualizations. This is an open source tool. It is open for everyone. You can just go with the Google and find this, and you can create interactive visualizations in the d3.js. You might have to write the JavaScripting code to create the visualizations from this. And we have some other tools. Data scientists need to be skilled with a wide range of this data visualization tools as well, and including the simple graphic tools for the business presentation and spreadsheet applications. But if you want to learn about inbuilt visualizations where the data visualization tools are offering right now, we have Tableau, Microsoft Power BI. Microsoft is Power BI. And we also have ClickSense. We have some other competitive data visualization tools available in the market right now. These are really good for the data visualization. The results can be shared skillfully with your internal communication platform, or you can even share with the outer communication whenever there is like no sensitivity in the data. And you can easily build or create the visualizations and do some data analysis out of this BI tools. You can easily give the whole understanding of your data, of whatever patterns you see, whatever trends you see in the data, to the final advisor in an easy format. This is like as the easy format of presenting the data to the final user. So the next part is we have learned the cycle, we have seen the tools, we have got to know what is tool is what, how it is going to be useful in our data part. So we will be seeing what are the prerequisites for a student to actually get into this data science program. And these are the four main things you need to understand, 5 things you need to get a knowledge on whenever you're having a career interest in mind in the data science field. So the computer programming terminologies, we have went through so many technical jargons right now. There is so much of process involved in the data structuring part, data cleansing part, warehousing part, etc. There are too many jargons. So you have to need to have a basic idea of what is what, which right now we went through. And these are the computer programming terminologies, like what is what. You can also say it as jargons. You have to understand what is what. So you have to be understanding of graphs and charts you're going to use. So how a visualization will be understandable to the final user. What visualization should I use? A basic understanding of how the representations should be whenever you're presenting the data. And a knowledge of MS Excel and SQL will be an added advantage. Like I said, SQL is a universal language that can be accessed with so many databases with this syntax for SQL is so common for all the databases. So the knowledge of understanding of Excel will actually help you to understand the data analysis well, and the knowledge of SQL will actually help you in the data structuring part. You can easily extract the data and pull some data whichever is needed. The understanding of SQL is like an added advantage for you. So you have to have the willingness to explore the data, even if you do not know what is coding, and even if you do not know how do I code. There are so many skill sets out there, but you might have to have this willingness of how to explore the data and how to learn the data, how to learn this terminology, etc. And the last one would be the basic database knowledge. And what are the databases available? How is the data stored? What is a database actually? And how are you going to access the database from different tools? And the basic kind of knowledge, it's already covered through in this particular, if I say in this particular webinar itself. So what is a database? How is the data going from here to there? What is the part which is happening in between them? So these are the five major prerequisites you have to have whenever you're moving a career into this data science. And data science, we call it as a booming trend right now. And what are industries gaining from this data science? So the industry trends can be the organization, these are using data science to turn their data into competitive advantage by just refining their products and services. So some of the cases, like use cases where this data science and machine learnings will come into use, is like they can determine the customer churn by analyzing the data collected from all these cost centers. So the marketing can take action to retain the customers, and the data collected from all the cost centers will give you the analysis part. So improving efficiency by just analyzing traffic patterns, weather conditions, and also factors so that the logistics companies can deliver the goods very fast and with reduced costs. So they have to do this data analysis, like how to understand the traffic patterns, is the weather is going to affect it today, everything related to data, and they can improve this efficiency of delivering. In the health care technology, if you want to improve your patient diagnosis by just analyzing the medical test data and reported symptoms so that the doctor can easily diagnose diseases earlier and treat them more effectively. So lots of the apps, like the pharmacy apps itself is collecting data whenever you're going for a test, and they are actually predicting some outcomes. Okay, this patient can be coming up with a disease, and they can actually suggest some treatments beforehand itself by just going with this all the data science concepts and predicting some value out of your data. So they can easily optimize the supply chain by predicting when the equipment will break down. They can easily optimize the supply chain by just analyzing that, okay, my equipment can be broke down in some particular time. And detecting the fraud in financial services by just recognizing suspicious behaviors and anomalous actions. And you can even identify the fraud and be careful about that. Even if you see here, all the data at the back end will be shared, saved somewhere, right? You can even predict the fraud beforehand and do some precautions beforehand itself. And if you just want to have the fun part, we can even discuss about what is happening with the data science, like companies with Netflix, Target, or Procter and Gamble. So these companies will use data to actually run and grow their businesses, right? So the fundamental goal of the data science is to help companies to make quick and better business decisions. So which can enable them to gain market share and industry leadership. Like Netflix analyzes your watching patterns to understand what drives users' interest, and they will use this information to make decisions on the next production series. So they will analyze the data, whatever you're watching, whatever it is trending, how are people selecting their movies or films or series, whatever it can be, and they wanted to invest on something. So what can be they investing on? What is the highest trending content, or what genre it is falling under? everything is coming under data science. Even the throwing of that your boxes, like you might be interested in this, that throwing itself is like following a data science pattern at the back end. If you see Amazon, it will throw all the products you might be interested on. How is it it's actually doing that? It is actually taking up your content. Whenever you're clicking on that link, if you're seeing some product, it will take that data and it will take the data to actually throw you the similar contents. There is a definite data science or AI or machine learning processes running at the back end to show you a similar content for your buying purposes. You might be like going to buy something, but you saw something else and you wanted to buy that also. This is like a perfect market strategy to go if it is just making you to go see some other products as well, to buy them as well. So it's gaining a lot from this data science program. And finally, it will improve the sales of whatever the business it is doing. Like we saw, Amazon is doing the data science program at this running. It's running some AI at the back end to actually show you so many products to buy, which has a similar content. And when you're seeing the similar content, you might go with a higher cost as well, which is the first one you're seeing can be a lower cost. But whenever you see the similar content, the higher cost that predicted will come onto your similar content, and you might be interested in that as well. So this is how they actually improve all the sales, and through the based upon your patterns, they will predict the patterns from the data and throw you all these things on your face. Okay, the final step, we are just entering into the career path and opportunities for you students. The career path for data science is like the hottest professions of the decade, and demand for data scientists who can analyze the data and communicate results with this data-driven decisions, it is getting higher and higher going forward. I don't know how the future will be going on. So many manual things, so many manual things which are done by the humans are actually replaced by this content, all the processes so far. So according to this LinkedIn survey in 2017, the number of data scientists have grown over 650% from 2011. That is actually a huge number, 650%. And we don't know how it is going in the future and how it is going to expect. IBM is telling us that, okay, the data science will be like increasing up to 28%. The demand will increase up to 28% by 2021, because this machine learning and data science are generating more jobs, and they are they have less experts to fill them, and they're like posting so many opportunities right now in this fast growing field. So if you, in the coming years, there will be a need of like 1,40,000 to 1,90,000 data scientists, and the data scientists average salary in US can be like $1,44,000 a year, and there is need for both the specialists and resources who generally understand the data and make a compelling career choice out of it. And data scientists will help us achieve some major goals that either were not possible or not required in the great deal a few years ago, but in the coming future, there will be a more requirement for this data analysts and data scientists, because all the companies are generating data. Let it be healthcare, let it be logistics, let it be entertainment. Every company is generating data. So the most interesting topic right now can be a self-driving car made by Tesla. It's like actually implementing predictive analysis over there to drive all these autonomous vehicles, and they're doing so much of data science at the back end. And if you see this entertainment business, because of this COVID situation, people are mostly going to this OTT platform, and this entertainment platform is actually doing so much more to predict out patterns from your data, whatever you have, and it is actually throwing up so much content on your face to which you might be interested on. So there are like the basic terminology say data analyst and data scientist. This can be confusing because it's like two sides of a coin. A data scientist, in order to help businesses, they make more strategic decisions from this large data sets, and they will identify trends, develop charts, create visual presentations, etc. from all these data sets, right? These can be called as a data analyst. But data scientists will be more focused on the designing and constructing of new processes for this data modeling and production. So data scientists might have to go through all the 5 stages of the data cycle. They have to go through everything. And data analysts can be doing something from the analyzing part to the final visualization presentation. So that is the basic difference between a data analyst and data scientist. But do not go with the terminology, because so many companies out there, they even have this data scientist named under data analyst as well. But the part they're doing, the work they're doing are more into the data scientist. So whenever you're creating or if you want to create a career path in this data science, and you need to understand what are the tools, and where are these tools falling in this complete data science life cycle, so that this one, you can choose between these two by just learning a specific tool in this entire data science career. So the most common job titles we are seeing right now in the data science is like we have data scientist, data analyst, data engineer, data architect. These two can be whenever they are doing the warehousing part, bringing the data from the other tools and sending the data to a data architecturing part, like they're using a database and they're actually storing everything data in the data warehouse. That can be data engineer and data architect. Business intelligence developer is a final one, which predicts the insights, which understand the patterns inside the data, and they can be called as business intelligence developers. They will be dealing with the languages like Python or SQL to extract and transform the data. They will be using this visualization tools like Tableau, Power BI, or ClickSense to provide insights to the final advisors. That is a part where the business intelligence developer will do. But the data scientist and the data analyst are the common terminology most companies are using right now, which might include each and every step in the data science. So this is the conclusion for our complete data science program and data analysis program. So we went through the depth detail of all the stages we have in data science, data analytics, all the tools we will be using, how is the career going to look at, what are the titles available, etc. So right now I wanted to stop and pause for any questions we have from the students.
Yeah, you have been, you can unmute yourselves and ask your questions, or if you're more comfortable, you can type in the chat box.
Yeah, ma'am, just wanted to ask what kind of, qualification is needed to be a data scientist?
Qualification.
Yeah.
Yeah.
What kind of studies somebody should take up?
Okay, so the qualification, basic qualification can be bachelor's, it can be BTech, a BE, or a specialization in computer science, IT, or even with the other departments like ECE, EEE, etc. can come into this field if they are like so much interested. The basic qualification can be a bachelor, BTech, BE. And some other qualifications can also come under this, like MTech, MS in the particular specialization. And they can also go through some specializations in the data science or data analytics part in different universities, and they can come back with and work with the companies which are doing this.
Thank you, ma'am. I mean, you mean to say that somebody who has done BTech in computer science, he might have extra advantage?
See, yes, they can have the extra advantage, but it's all dependent upon the career choice where the student is making. If they're like most willing to learn whatever it is from whatever the courses you're going through, your basic qualification might not be the important one over there. The knowledge you're having on that particular field will be important. So the basic can be beaten, even if you're from a different field.
Okay, thank you, ma'am.
No problem.
Ma'am, if we can add, Shineha, as you know, data science is going to like across domains, it's going to be playing an important role. So even if you're a mechanical engineer, you can do like supply chain related analytics, or so many things are up and coming right now.
Yes, you're 100% right.
So ma'am, a couple of questions in our chat box. Ma'am, Jyotsna asks if it's is it legal or illegal to take private data from users, consumers, basically.
That's a very good question. Okay, I'll take the example of LinkedIn. If you say web scraping is like scraping the data on the website of whatever you have. You can even create a similar looking website also whenever you're doing with some websites, but it's kind of legal for some websites and it's kind of illegal for some websites. And if you want to take the LinkedIn as an example, LinkedIn, it is illegal because they have a copyright. Whenever you're doing this web scraping, you have to check for the copyrights, whether that company is allowing you to take the data. But if you want to get the data from other data sources, there is one particular site called Kaggle. They have different data sets and you can actually get the data from there.
Thank you, ma'am. Pranav asks, he's asking more about our course that we are providing. I'll answer this, ma'am. Okay. So Pranav, once the Q&A session is over, I'll play a short video of our co-founder, Mr. Sarang. He'll be explaining our postgraduate program in data analytics and data science. It's an in-depth video of what are the topics we'll be covering and the project portfolio you'll be taking underneath it. I hope that answers your question, Pranav. Ma'am, we have another question. What do you like? What would you advise for a second year BTech IT student to do right now if he or she is focused on a career in data science?
So I actually advise to even if your college is teaching you all this theoretical content for you right now, but I'll be totally honest, the practical content in the real-time scenarios might be missing sometimes. Okay, you will be learning all the theoretical content, you will be doing all your lab programs, but if you're taking some course out of it, and if you're also going to learn the practical content of what your real-time world is doing, it will be a very good positive for your interview you're going to coming up with your final interview, whether it can be a placement or if you are going up with an interview with an internship, or if you're going to come with an interview directly with the company. It will give you so much knowledge to answer the questions then and there, because all the interviews you're facing and this will be logical, because it has to be related to the data and how you're thinking about the data, how logical are you thinking will be gained from the interview process. So if you're going to your if you're in the second year, just take an internship in some company on the data science, or just go with a program where it is teaching real-time experience. So that might help you a lot.
Thank you, ma'am. Sauvik asks, I think he's a finance enthusiast. He asked, in stock markets, all these charts are made, right, ma'am? So he would like to know, what kind of tools are used in such cases, if for traders, what kind of tools they should learn.
Okay. So the final chart you're seeing on your stock markets is coming from some data visualization tool. It can be anything. It can be directly from Google data visualization, because Google has this D3.js, and it can use other visualization tools as well. And the models they are bringing at the back end, they are actually taking the historical content and they're throwing you the current scenario, and they're actually throwing the predictive analysis, how it is going to be sometimes. And all the stock markets are completely based upon the data, whatever you get inside. So whatever that falls under data science, the analysis we spoke about, the predictive, diagnostic, descriptive, whatever it can be, it fits according to the data at that particular point of time. So for the stock, if you want to predict the future, you will go with the predictive analysis. But if you want to see the diagnostics of how the data is looking around, you will go with the diagnostic analysis. And the tools they will be using for this is, they will be using this languages like SQL, Python, to actually do this analysis from the data. And the final chart you're seeing is actually coming from the visualization because they saw some insight, extracted some insight, and showing you there the visualization.
Thank you, ma'am. We have a couple of questions that are relevant from Anuja and Saurabh. Like people from commerce or medical background, medical as in I think he means bioengineering, biotechnology.
Okay.
So like, do they have scope to continue learning in this field?
Okay, I might be the important person. Like, see, my studies are from biotechnology. I'm a graduate degree from biotechnology. I come from the science field. But if you have the zeal to learn the content of whatever tools they have, I don't say the bio people will not stay behind at the max because they will also have max in their curriculum. And if you look at the medical field right now, and they are also doing some data science program at the back end to predict and diagnose the diseases or medical diagnostics, and there are so many things happening in the medical field as well if you're like so much interested in the life science. But you can always go with the other domains like sales, finance, or whatever, because the tool is same, the process is all same. If you have the knowledge, you can go with the whatever domain it can be. Maybe it is related to life science or maybe it is related to other domains. It's not a big thing. Learning is actually a big thing, and if you want to learn that, you can still go with that data science or data analytics.
Can I add, like, my friends are in actually in pharma data analytics, like all the big pharma companies actually.
Yes.
Yeah. So I'd like to add that one.
Yeah, even the pharma companies are using data analytics.
A question from.
Yeah.
Sorry, ma'am. Go ahead.
See, it's like we have this clinical trials. If you like, so many people are upfront with the data right now. They also know about the clinical trials because our condition. All the clinical trials data we have at the backside, right? And it is stored somewhere. And all the drugs they are releasing, all the trials they are going under, and where it is right now, which clinical trial phase it is under right now, or where it is produced, where it is sold. Everything is actually data. So all the pharmacy companies is also going through all this process, like I said.
Thank you, ma'am. Question from Mirza: is neural network necessary for data science?
I should say no. I mean, completely. It's like it is an added advantage, but not completely.
And that's all the questions from my end. Students, if you have any questions, please feel free to unmute yourselves and ask ma'am directly, or you can post in the chat window. A couple of you are asking about the attendance sheet. We'll be sharing it after the, like I said, we'll be playing a short video after this. We'll be sharing the attendance sheet after that. Ma'am, Atul asks what are the important topics for data science in mathematics?
Directly in mathematics, see, it's not like what are the important topics. It's about the logic formulas you are using. So whatever you study or you're studying in your field right now, there will be some formulas, right? It is all going into the analysis part you do inside the data structured part. The tools you're using right now, if you just say clustering, the clustering will use a formula at the back end. That's called a math. And the formula you're using right there is it's like you have to understand how the formula is going right there to solve a problem. That's where you use maths. It is not like an important what is the topic, but what is the formula it is using at the back end for your analysis.
Thank you, ma'am.
Yeah.
Ma'am, I think we can close the queue. Sorry, ma'am. One more last question.
Yeah, no problem.
Data science allows the capture of data from users for betterment. Like FB and Insta takes data from its user, reading messages and tracking the user's activity and throwing ads. This also brings about privacy issue. So
yes.
Technically, it can be used to spy on specific targets.
Yes.
What do you think about this?
See, there is always a legal notice at the back end of how they are going to use the data, but I'm not sure how much of a percentage of they are going through with all the legal notices at the back end. If you just go to your Instagram and just go with the legal notice about your data, okay, we are not using your data anywhere. Your data is safe and secure, but it is actually running through at the back end somewhere. They have the possibility, look, but it is illegal. If I say they shouldn't do that, but for the ads purpose, they can still throw up some ads, but they say we are not using your data, and but they still throw up some ads. It's like seeing the similar content whenever you're buying something on Amazon, but they still say that we are not tracking anything. Your data is totally encrypted. I'm not sure how much encrypted it is.
Thank you, ma'am. Yugadya asks, they are a biotech second year students and they are learning R software as part of their academic curriculum.
Okay.
They would like to know how to do more practical oriented session. I mean, more practical oriented projects in data analytics.
Okay. So R is a good platform to learn the language, and you will get all the libraries to cleanse or clean your data and manipulation also. So if I heard that you are studying biotech, and if you have this biotech content, you can easily access the life science data if you're like so much interested, because it is easily understandable for you right now. And if you want to get some data, there is always so many platforms available out there which produce your data. You can go with even the government sites and actually take some data out of it, and you can do the manipulation. Let's say take a data set which is unstructured, like it has nulls or it has unmatched values, etc. like that. Take a data set from available content over there, the platform over there, load it into your R and do some analysis, do some structuring, like replacing one column or replacing one cell, do some text analytics. Maybe you can do that inside R, and you can get a project out of it. Text analytics is also an important one, and you can do it with R and predict some outcome out of it. Like how is my data, and what are the insights I can give to the finance advisor, and it is completely based upon your I mean, it is totally your interest to what kind of data you're looking for. You can do all the things from R. So the real-time project can be take the data set, analyze the data set, manipulate the data set, create your own problems, and just keep a goal. Okay, I need to answer this kind of question, and just get the answer out of it. That can be your real-time project.
Thank you so much, ma'am. I think we can close the Q&A now.
Okay.
Ma'am, if you can please share the host status back to me, I'd be able to play the video from my end.
Sure, give me a second. And thank you so much for attending the webinar today, and happy learning.
Thank you, ma'am. Thank you, ma'am. It was a very interesting session, in-depth analysis, like in-depth details were given to me.
Thank you so much.
Students, I'll play a short video on our postgraduate program in data science and data analytics. Our founder, Mr. Sarang, will explain all the intricate details about the course, about the modules and the projects you will be completing as part of the program. If you are interested, I'll float a form at the end of the session. We are running an exclusive campaign as part of Mood Indigo, where you would get a 50,000 off on our postgraduate program. Let me share the video now.
Hey guys, hope you are doing good and welcome to a new video. So today I wanted to talk about our new postgraduate program in data analytics and data science. This is a fairly customized and unique program, and it essentially contains two aspects. So there is an offline aspect to it where you would be coming in and taking up 5 programs in our offline skill centers, and then there will be 4 courses that you will be taking online, right? So what I'm going to do is I'm going to be explaining more about what these courses are and how they have been designed and what is it that you will be gaining from them. All right, so now let's talk about the courses that are actually covered in the offline program. So if you look at the offline program, the way it is structured is that you will first learn the basic maths, because at the end of the day, data analytics and data science it's all about making sense of numbers. And the way you would do that is by having a firm understanding of key concepts in statistics, probability, and linear algebra. So once this is done, we will actually take you to the most easiest way to perform data analytics or data visualization, which is using Excel. In 2021, we have a lot of tools, Power BI, Tableau, a lot of plugins and modules that can be built, that can be added to Python to do data science or advanced data science. But majority of the work can be accomplished by actually using Excel to do a lot of lifting with respect to data science and visualization. So in Excel, the key things that we will be focusing on is how to basically code in formulas through which you can accomplish key objectives, and then how can you actually group together formulas and convert them into reusable functions. And when you're doing this, one of the things that you will always encounter is you will get a lot of errors in the data. How would you handle errors in data using Excel? That's a key focus. And then we will be learning concepts such as pivot and goal seek. And to understand these two concepts, what I've done is I've actually added an example there, and we'll be taking a look at that. So here, what I've done is I've created a very small table. So the table contains 4 columns. The first column essentially explains the product that we are essentially selling. So I've given very simple names, A, B, C, D, and E. The second column indicates the type of product. And to make it simple, the product types it can be a triangle, a square, or a circle. And that is actually added here. Then we have the cost of the product, which is listed in dollars, and then the profit that you can actually get from each of these products. Now, one of the common business use cases would be to understand, okay, how does my profit change depending on the product that I'm trying to sell? So what you have to do is, you have to take this original table where you are essentially looking at products and then you're looking at the types, right? Instead of looking at products, you have to essentially pivot this and you have to look at the types, right? So for each type of product that you have, you need to look at what's the total cost of goods that has been sold, what's the count of goods that has been sold, and what's the profit for that particular product line. And this, in some sense, is what pivot table is all about. You are essentially looking at a different dimension of the data, and you are basically looking at key quantities such as sums or counts, which are what you call as aggregates, and you're looking at the value to essentially understand the data in a much better way. While you're looking at this, you're looking at just the product-wise data, but then here essentially what you're able to see is that the total sales is highest for Square product, has resulted in the max number of sales and has also resulted in max number of profits, right? So this is what data science and data analytics is all about. It's about making sense of data. And from going from the original data set to this data set, this is done using pivot tables, right? Now you can accomplish the same thing in Excel. You can do this in MySQL using aggregate functions and group by commands. And you can do this in Python with something like pandas, right? But the whole idea is doing this in Excel at the end of the day is the easiest way to understand these key concepts. Now the final concept that we would be learning in the Excel course is goal seeking. So for that, let's pay attention to this particular table. So here we have looked at, for each type of product, we know what's the number of count of goods that has been sold and what's the profit that we have made. Now let us say that we ask the question, hey, how many items of circle or how many circle products do I have to sell in order for my profit to be $36, right? Now in this particular case, the math is so easy that you can compute, but say that you have thousands of products, then that might not be so easy. This is where the goal seek functionality comes into play. And what the goal seek functionality does is, it tries to figure out the number of circle products that you have to sell, or in other words, the count of circle products, so that you affect the total profit. So the goal is to essentially change this $21 to the target number, which could be $36 or $40 or whatever. And the input that the solver would change is the count of products that are of type circle. All right, I hope that makes sense. So that basically concludes our Excel module. The next module is MySQL. Now, as I mentioned before, majority of your data analytics and data visualization can be completed using Excel. If you're an organization where you're dealing with, say, data sets that are 10,000 to maybe up to 50,000, then using Excel is what all you need. You don't need to use MySQL or something more advanced than that, right? However, let us say that you are working for an e-commerce application where you're looking at millions and millions of product information, right? Now, typically, the way the e-commerce companies would store this data is they would not rely on something like Excel. They would rely on something like MySQL, because that way the data integrity is far more higher and you can protect the data in a much better way. So when you're actually having a MySQL database, essentially anything that you would do in Excel, you should be able to do that in MySQL as well. We are actually having a dedicated course on MySQL, which is a relational database, where apart from learning key concepts like writing a function to calculate the sum of a column or doing simple aggregates, you'll also be learning something called as joins. One of the key features of relational database is that you can use something called as a primary key, and using the primary key you can link data across multiple tables and then do aggregate functions on them. And this is what we would be covering in the MySQL module. And a few additional, say, advanced concepts that we would be talking about are subqueries, which are commonly used while handling large amount of data. The last but one module that we will be learning in our offline
Guys, request everybody to mute themselves. There are other people watching the video.
ऐसा पर से क्या कम रेट दूंगा, अगर बताओ 50-75 रुपए की कमाएंगे तो कैसे काम करेंगे? कह रहा हूँ 1% की कमाएंगे तो काम कैसे चलेगा? 60 रुपए की कमाऊँ 6500 का माल बेची।
Sorry about that. Let's continue.
Module is Python. So typical use case in a company would be to essentially fetch data that you want to visualize or analyze, and you would essentially fetching that data from a relational database like MySQL or a non-relational database like MongoDB. However, you need to know how to fetch that data using modules that are actually either existing in Python or have to be installed and imported. Now, once you are able to fetch the data, you need to understand what the process of data analysis would be. Are you going to be pivoting your data set, or are you just going to be computing direct statistical quantities? That is something that you will have to code it in. The key difference is in Excel, you probably have a button or you have a simple function that already does this for you. Whereas in Python, it's very important for you to code it yourself, right? And that is why the math, the first course is very, very important, because if you're trying to implement a function yourself, then you need to understand how it's actually done. You need to be able to first solve it using pen and paper. Only then can that knowledge be ported into a programming tool, right? So that's why it's very important to have very good understanding in maths. Then you will be able to do the second piece of the Python programming very well. The third piece is visualization. One of the core advantages of learning Python is that the visualizations, there are so many visualization libraries that are freely available that can be used in Python, and you can essentially customize it to your organizational needs as much as you want. However, there is a learning curve. In this program, we will be looking at Matplotlib and Seaborn, through which you will be able to visualize the data that you have fetched from a MySQL instance. All right. The final piece is essentially learning a commercially available visualization and analytics package like Tableau or Power BI. So what's the advantage of doing this? By learning the first 4 modules, you would have completely understood how the data analysis pipeline works, right? How do you fetch the data? How do you clean the data up? How do you process the data, and how do you visualize the data? However, going through Excel or doing this through Python can be a bit cumbersome, especially if your organization needs result in a quick manner, the data is changing on a day-to-day basis, and you are essentially preparing this data set for, say, someone at the upper management who does not want to run Python programs, for example, to change a variable. And this is where tools like Tableau or Power BI comes in, where what you would do is you would essentially set up the key visualization views that you want, key dashboards that you want, and you would give very easy to use controls that someone in your upper management can just change and see how the results change like. And that is why we have actually included Tableau, right, or Power BI. In other words, if you do a good job with modules 1, 2, 3 and 4, you would have completely understood how data analytics and visualization is done. Learning a commercially available data analysis and visualization package is going to be a huge plus point. All right, so I hope that was clear, and that actually concludes the programs that you would be taking in an offline mode. So now let me talk about the online modules. So the key differentiator is that the offline program essentially prepares you for roles where you have to handle data, you have to clean up data, and you have to visualize data. And this is where the majority of jobs are there in today's market. Companies in the likes of KPMG, Deloitte, TCS and CTS, if you look at their job openings, this is where the majority of jobs are there today. However, if you want to essentially get more on the technical side of data analytics and visualization, that is where the online module courses are going to be very, very helpful. So here the focus is on machine learning, deep learning, data structures and algorithms, and finally you would learn Tableau or Power BI here as well. So anything that you would miss, for example, if you learn Tableau in the offline course, you will actually learn Power BI in the online course and vice versa. So let me talk about the structure of this particular program. So here the focus is more towards how data visualization tools actually work. So if you look at the online courses, the focus is more towards how the data can be analyzed to essentially predict outcomes. See, for example, whatever we have done so far here, we are just, we actually have data, and then what we are doing is based on that data, we are actually deriving some key metrics, right? We are deriving key metrics. We are essentially doing some aggregate functions to understand total sales of a particular goods, right? So that's what we're trying to do. However, let us say that we want to figure out, based on our old purchase pattern, we want to figure out how many triangle units would be sold in the next month or for the next quarter, right? Then you will need some type of predictive modeling capabilities, right? So that's a branch of statistics called as inferential statistics, and which is essentially the root of machine learning and deep learning in some sense. So in these courses, the focus is towards how to actually build your own machine learning models from scratch in Python. And that is the focus of the first course. Here you will be using Python a lot, and you will be applying a lot of mathematical concepts, which are essentially the backbone of commonly used machine learning algorithms. So once that is done, you will actually learn data structures and algorithms. Why is that? Well, if you look at machine learning jobs or jobs in the sphere of data analytics, data visualization, and modeling, you have the larger chunk of the jobs in essentially understanding the data, right? Just by cleaning it up, just by plotting it and understanding it. However, the other set of jobs essentially lies in preparing software or creating software which can help you in better modeling capabilities and prediction capabilities, or software engineering jobs where you're using third-party AI and ML models to make sure that your application's predictive capabilities are much better. And that's why data structures and algorithms is very important, because if you're going down this line, you are essentially trying to apply for software engineering jobs where data structures and algorithms is extremely important. Deep learning is essentially added as an addition here, because someone who is more oriented towards the mathematical bit, if you are interested, I think deep learning is something that you will gain a lot of value from. And finally, the additional visualization tool that we have added. Typically in the market, the jobs are split across Power BI and Tableau. So if you are learning Power BI in the offline center, you would end up learning Tableau online. All right. So in total, in the PG program in data analytics and data science, you will be taking up 9 courses. 5 of the courses will be completed in the offline skill center. All right, with that, I would like to conclude this video. Thanks a lot for taking the time. Bye.
Hi, everyone. So, as you might know, the postgraduate program in data analytics and data science is a combination of offline and online. We have our offline skill centers in 4 cities right now. However, you can choose to do the course entirely online. It covers over 9 modules and about 20 different projects across all the modules. I'll be sharing the attendance sheet and I'll be sharing our link to the exclusive offer in the chat window. Do make sure to fill your attendance sheet to get your certificates. Thank you everyone for joining the workshop, and all the best. I floated the attendance/feedback sheet in the chat window. Please make sure to fill it up.